Hello everyone, we are RGA Tutorials, and in today's video we're going to be going over some topic questions for the topic atomic structure. Alright, let's begin. So the reaction shown occurs in gas clouds throughout the universe. So H2, that's hydrogen gas, plus H2 plus gas forms H gas plus H3 plus gas. That's hydroxonium ion right there. So now what would be the atomic structure, so the number of protons, neutrons and electrons for hydroxonium ion? Well, we can see it has a plus here, and if you go to previous videos we explain how a positive ion shows an electron has been lost, not gained. So the number of protons, it's definitely going to be higher than the number of electrons. So it's just a point to rule out some options for the multiple choice. So now we know because it's a positive ion, the number of protons cannot equal the number of electrons, so D would be out of the question. We can go on to say that since it has 3H3, it's going to have 3 protons, and since it's lost an electron, it's going to have 2 electrons, and then it's going to have 0 neutrons, so the answer would be B. So now which row is correct? So now the atomic number is the number of protons, the proton number is the number of protons, and the mass number is the number of nucleons, so the answer would be D. Okay, so now to the next question. So now the phosphide ion, P3-, is used in medicine as a radioactive treatment for some forms of cancer. So now what is the composition of phosphide ion? Okay, so we can see the denotation here. Okay, so now the number 15 is the number of protons. That is the atomic number. Number 32 right here is the number of nucleons. That is the mass number. And there's this basic notation for proton number and mass number. So X would be our element. So in this case, the phosphide ion. Then the 15 would be A, that is the atomic number. 32 would be Z, that is the mass number. So now it's going to have 15 as its number of protons. So we can see here it's a negative ion, but it doesn't just say minus, it says 3-, meaning that 3 electrons have been gained. So in the case where we have phosphide ion, 3-, 15, 32 up here. We're going to have 15 protons, but since there's a 3- up here, we do 15 plus 3, which gives us 18. So 18 for its number of electrons, and what's its number of neutrons going to be? Its number of neutrons is just 32 minus 15, which equals 17. So the correct answer would be B. Okay, so now which option is correctly describes the relative charges and masses of the subatomic particles? Again, if you go on to our video on atomic structure, part 1, you're going to see a table, or at least there's a table shown. But just for the context of this question, the number, so protons, they have a positive charge, neutrons are neutral, electrons have a negative charge, and the relative mass of an electron is going to be 1 over 1,840. So the correct answer would be C. So now the trajectories of subatomic particles shot through an electric field producing a vacuum are shown in the diagrams. So now which diagrams would be correct? So remember, when subatomic particles are shot through an electric field, electrons are always going to be attracted to the positive field, while protons are always going to be attracted to the negative field. So in this case, where protons are attracted to the positive field, this is wrong. When neutrons are not attracted to either the positive or negative field, this is correct. And electrons are attracted to the positive field, this is correct as well. So the correct answer would be 2 and 3, that is A. So now which row correctly describes the characteristics of the nucleus and surrounding space? So now the surrounding space is mainly empty space, right? So the answer is either going to be A or D. Now the nucleus is small, dense, and positive, so the answer is D. So now X is a particle with 19 electrons and 20 neutrons. So the species are shown below. That is calcium with a mass number of 40, potassium with a mass number of 39, and argon with a mass number of 38. So which of the three species could X be? Okay, so they said it has 20 for its number of neutrons. Let's consider number 1. Number 1 is calcium, which has a mass number of 40. So if it had 20 neutrons, it would be expected to have 20 protons. So 20 plus 20 makes 40. And since it's a positive ion right here, we can see that it has lost 1 electron. So number 1 is correct. In the case of potassium, if it were to have 20 neutrons, then it would be expected to have 19 protons. But since it has a positive charge, the number of protons would be 20, so number 2 is incorrect. And in the case of number 3, if its mass number is 38 and has 20 neutrons, it's expected to have 18 protons. But in the case where it has 19 electrons and it's neutral, it's going to have 19 protons as well, which means only number 1 is correct. So the correct answer would be A. So now which of the following statements describes a free radical? Remember, a free radical is basically a species that has an unpaired pair of electrons. So a species with a lone pair of electrons, a species with a half-filled d orbital, a species with 1 or more unpaired electrons, and a species with a partially filled outer shell. The answer is going to be number C. So now, in which of the following species are the number of protons, neutrons, and electrons all different? Okay, so now in the case of sodium 23, in the case of sodium with a mass number of 23. Alright, as I was saying, in the case of sodium with a mass number of 23 and a positive ion, sodium has an atomic number of 11. So since it's got 11 protons, and by extension it would have 12 neutrons, you can see here that it's a positive ion, so it's lost an electron, so it's going to have 10 electrons. So sodium is the correct answer. So now, which statements correctly describe the distribution of mass and charge in the atom? So now, the negative charge is concentrated in one area outside the nucleus. The mass is concentrated inside the nucleus. That's correct. The negative charge is spread around the outside of the nucleus. That's correct as well. So it's going to be 2 and 3. So that's C. So now, what is the electronic configuration of the ion with a single negative charge and the atomic number of 17? That would be chlorine, except because it's got a negative charge, it's going to have an additional electron. So it's got the electronic configuration of argon. So let's go over number 1. 1s2, 2s2, that's 4, 2p6 is 10, 11, 17, no. B is the answer. So now the isotope cobalt is used in the treatment of cancer cells in the body. Which statements about this isotope are correct? So now the charge on the nucleus is 27. No. There are 33 neutrons in the nucleus. That's correct. It has the same number of neutrons as other isotopes. No. So 2 is the only correct one. So it's C. Thank you so much for listening. Hope you tune in for the next video. Have a lovely day and make sure to subscribe.